These are the notes about the moon, our nearest neighbor in space. What is the moon? It's a natural satellite, and as we know from GPS, satellites orbit the Earth, so the moon is our natural satellite. And it's one of more than 96 moons in our solar system. But it's the only moon that belongs to the planet Earth. It's all about the location. It's about 384,000 kilometers or 240 miles from the Earth, and it's about 3,500 kilometers in diameter, which is about the quarter of the size of the Earth. The birth of the moon. It was born 4 to 5 billion years ago, and it formed from an impact of a Mars-sized object with Earth. So as we know, the Earth is 4.6 billion years old. So sometime in the early stages of when the Earth was forming, this Mars-sized object, which is shown here as this blue thing, collided with the Earth, which is the green object. And if we follow this around, you can see how the blue object kind of cuts out part of the Earth, which would be that greenish yellow object. And then you get all of these particles eventually that hang around the Earth. And as the Earth continued to cool from this impact, and as it continued to form, and now as these particles are all around the Earth, they're going to cool and turn separately into the moon when the Earth cools and turns into, as we know, the Earth to be now. So debris from both objects melted together to form the moon. The moon's surface. The moon doesn't have an atmosphere. There's no liquid water there. And there are extreme temperatures because there's no atmosphere. And then, of course, because there's no atmosphere, it's got much less gravity than Earth does. And a lot of times we say there's no gravity, but there really is gravity. It's a sixth of the Earth's gravity, which in comparison to what we know as the Earth's gravity is much less. And of course, at daytime, really hot temperatures, nighttime, really cold temperatures. Some lunar features on the Maria, originally thought to be seas by early astronomers. Maria, seas. Mar, we know, means sea, so that's why it's called seas. These are the darkest parts of the lunar landscape. These flat, smooth, darker features are the Maria, and they're filled by lava after the crash of huge meteorites on the lunar surface 3 to 4 billion years ago. And the moon, as well as this Maria, is mostly basalt, which is that darker igneous rock that we talked about when we were doing the rocks and minerals unit. And then here in this picture, there are craters from impactors, things that have hit the moon. Round things here are called craters. And then when you have these small impactors on the Earth, or excuse me, on the moon, the surface kind of puts out what's called a ray. And when that impactor hits, it gets this extra stuff that kind of gets thrown off, and those are the rays. And then here's a picture of the Maria pointed out there. Movements of the moon. A revolution of the moon. The moon orbits the Earth every 27 and a third days. The moon rises in the east and sets in the west. The moon rises and sets 50 minutes later each day. That's why when you look up in the sky, the moon's generally not in the same place for more nights than just one. And the moon rotates on its axis every 27 days. So basically, that's why the same side of the moon always faces the Earth. And I've got another slide here that essentially says the same thing. The moon takes 27 days to revolve around the Earth, to go around the Earth, and the moon takes 29 days to make one rotation. So I actually need to edit the slide before here. The rotation, right here, takes 29 days. So for the moon to turn on its axis, it takes 29 days. And because both of those numbers are really similar, That's why we don't see the far side of the moon. And then here's some information about the far side of the moon. It was first seen by Luna 3, which was a Russian space probe in 1959. And the surface features on the far side of the moon are different from the side near us. And there are more craters because it's not protected from the Earth on the near side. There are very few Maria because there have been so many impactors and craters made on that far side of the moon. And it's got a thicker crust. And taking a look here at this picture, you've got the Earth, and then obviously there's only one moon, but two different pictures of the moon's location here. The plane of the Earth's orbit is sort of diagonally this way, whereas the plane of the moon's orbit, or the lunar orbit, is flatter. So the Earth sort of moves up and down, whereas the plane of the moon's rotation, or revolution rather, just kind of stays flat, which is what helps create eclipses. And the solar eclipse, which is when the moon passes between the Earth and the sun. So the name is whatever of the thing gets, excuse me, whatever gets blocked out. A solar eclipse means that the sun is going to be blocked from view. So we're here on the Earth. The moon comes between the sun and the Earth and blocks the sun from our view. So as we fill in these big circles here, the big circle is always going to be the sun. Middle-sized circle is always going to be the Earth. The smallest circle is always going to be the moon. And then the different locations for the shadows that are created. The darker shadow of the moon casting onto the Earth is called the umbra. And the penumbra is a partial shadow. Partial shadow, that is cast from this sideways angle. And then here's a picture of a solar eclipse. Got the moon coming through, blocking out the sun. The moon moves between the Earth and the sun. The moon casts a shadow on part of the Earth, but the total eclipse is only on one area of the Earth at a time, as we saw in the picture before. And the eclipses are really rare. These solar eclipses only happen once every 360 years. So most people will never see one in our lifetime, but you guys are going to be lucky enough to be able to see one in your lifetime on August 21st, 2017. So try to remember that date here in a few years and try to maybe find and go to where this North American eclipse is going to be in 2017. A lunar eclipse. Again, whatever is in the name is the thing that gets blocked from our view. So in a lunar eclipse, the moon is blocked from view. The Earth passes between the moon and the sun. And of course, the big circle is the sun. The medium-sized circle is the Earth. The smallest circle is the moon. And because the Earth is much larger than the moon, it blocks all of the sunlight towards the moon so that there's no light shining on the moon, which is why the entirety of the moon is in the umbra, that direct shadow, and the penumbra is cast out around the moon, which isn't really obviously involved in the whole eclipse. And then here's a picture of a lunar eclipse occurring. You can see the moon, and this is the shadow of the Earth passing over in front of the moon, blocking out the light to the moon. The moon moves into Earth's shadow. This darkens the moon. And these happen about 2 to 3 times per year, and they can last up to 4 hours. And now into the phases of the moon. It's just a phase. Moonlight is reflected sunlight. Half of the moon's surface is always reflecting light, but just from Earth, it changes our viewpoint as to how much of the light we can see that's on the moon. So we see different amounts of moon's lit surface, and then the amount that we see of that sunlight is called the phase. And this is a nice progression of all of the different phases the moon can be in. There are 4 main shapes. Full moon means you can see the entire circle. A crescent, just like a Pillsbury crescent roll, kind of looks like if you were to turn it on its side. A quarter moon. Now, obviously, this looks like half of the circle is illuminated, but actually, it's only a quarter because you have to think about the fact that there is an entire circle being shown sunlight, but we can only see a quarter of it. Because remember, this is going to be a three-dimensional feature, and we only see a quarter of that three-dimensional figure. And then the gibbous moon, it's this odd sort of oval shaped. Gibbous is kind of a weird word, so the shape is sort of a weird shape. I think about it that way. And to fill in the phases of the moon, when you see no moon, it's called a new moon. No moon, new moon. And then when it's completely filled up, it's a full moon. You got a third quarter moon, a first quarter moon, waning crescent. Waning means that the amount of light is getting smaller. Waxing gibbous, waxing crescent means that the amount of light is increasing. And then sort of a way to remember that is that if it's bright on the right, there'll be more light. So it's a waxing moon, it's moving toward a full moon. And then if there's light on the left, then there's little time left. We're moving towards a new moon. We're getting rid of the amount of sunlight there. And then here's another way to think about it. A waxing moon means that you're increasing the amount of light. These should be switched. Sorry, I wanted to fix that slide to make it correct, because as you're waxing, you're going to increase the amount of sunlight, reaching a full moon, and then after the full moon, you're getting rid of the sunlight, moving towards a waning moon. And then, of course, we know the tides are because of the gravitational pull of the sun and the moon and its effect on the water on the earth. The tides are caused by the pull of the moon's gravity on earth. A high tide is created when the sun and the moon are pulling the earth away, or excuse me, pulling the water away from the earth. The side facing the moon and the side away from the moon. And then every 12 hours and 25 and a half minutes, you have a high tide. Every 12 hours and 25 minutes, you have a low tide. So sometimes they're separated by about 6 hours. And then those are going to be happening on the opposite sides of the earth. And now to talk about space exploration a little bit. We'll watch a video in class about this, but I got to touch on it a little bit here. Mainly started in the 1950s. 1950s and 60s, we really had probes. We didn't send anything manned to the moon. But Neil Armstrong was first man on the moon in July 1969. And then there were 6 Apollo missions after that until 1972. And over the course of those missions, they brought back about 842 pounds of moon rocks. And then those are on display around the country. 12 Americans have walked on the moon. And then here's a picture of an astronaut on the moon. And just like on Earth, we label and named all the different features on the surface of the moon. We've got different oceans, different features. Looks like they're named for a lot of different scientists. But when will we return back to the moon? Nobody really knows. A lot of the funding for the space programs have been cut with all of this budgeting issues that we've been having the last few years, and in the future with all the furloughs and everything. It's probably fairly unlikely that we're going to be going back anytime soon. And for a little bit of ancient astronomy, the geocentric model was the early belief that the Earth was at the center of the solar system and everything else revolved around it. Geo means Earth, centric, center. So the Earth being the center of the universe was what everybody thought originally because, well, we're self-centered. But we were able to find out later from Copernicus that the heliocentric model was actually correct. That was the belief that the sun was the center of the solar system, and the Earth actually revolved around the sun. Helio means sun, centric, center again. And this was a belief that got many early astronomers in really big trouble with the governments, and lots of people got locked up for believing this because it went against what everyone thought was true. Just like everyone who said that the earth was round was wrong because the earth had to be flat. But no, we found out later that it's round, and actually, just like in this case, the sun is the center of the solar system. Kepler found out that each planet moves in an elliptical orbit, which is kind of like a stretched out circle, almost closer to an oval. Planets speed up in their orbit as they approach the sun because of the gravitational pull of the sun, and then slow down as they move away from it. And then here's a nice little comparison with the moon next to the Earth.